Okay, is it visible to all? Okay. So we will have a very quick revision of this unit, impurity in the pharmaceutical substance and the limit test. This unit will be comprising introduction first, then sources of impurity, effect of impurity, method used to purify the inorganic substances, test for purity, and at last the limit test. As we are knowing, impurity is a foreign matter which is undesirable, which is likely to be present in your pharmaceutical preparation. We will be having some ingredient for each pharmaceutical. Beside this ingredient, if something is there that is unknown, undesirable, foreign something, and we don't wish it to be present in the pharmaceutical preparation, it will be called impurity. Impurity will be affecting the standards. How? It will be affecting the quality, it will be affecting the safety and efficacy, because some of the impurity may be toxic. So that is why we are looking for the impurity and testing the impurity. Okay, so one more time, impurity is foreign undesirable matter which is likely to be present in the pharmaceutical. And one thing, why we are allowing this impurity, why not 100% pure compound we can have? Because it is time consuming, it is involving a lot many time, it is involving manpower for a significant amount of time. That is why we go for optimum quality that is required, that is mentioned by the high authorities, regulatory bodies. So we will simply go with the optimum quality only. We won't be going for the 100% purification. So traces of impurities are even allowed after a successful investigation and after studying that impurity are not having any toxic effect and relevant study. We are allowing some small amount of impurity in the pharmaceutical preparations. Impurity are undesirable element or substance that are commonly contained in the some compound, and which will be lowering the quality of the compound. Impurity are either naturally occurring or it may be formed during production. So while we are manufacturing any dosage form, due to the process factor, it may be generated. So it may be purposely, accidentally, inevitably, or incidentally added in the substance. A compound is said to be impure if it is having foreign matter. A compound which is not pure is impure, and a compound that is having impurity, that is foreign matter, is impure. Okay, a compound is said to be pure if it is free from foreign matter, that is impurity. A list of impurity which are likely to be present in the given pharmaceutical substance can be easily compiled from the knowledge of the raw material, manufacturing process, and the final product. For an example, if you are knowing the preparation of calcium carbonate, that you are adding sodium carbonate, you are adding calcium chloride, and you are knowing that the byproduct getting generated along with the calcium carbonate is sodium chloride. So you are having this knowledge from what? You are knowing the manufacturing process of this calcium carbonate powder. You are knowing the dosage form preparation process, raw material which are used for the manufacturing. So this is how you can have the knowledge of impurity from these processes. Impurity can come from variety of the sources, and one of the favorable question is what are the sources of impurity? And sources of impurities are raw material, then some factors due to the method of manufacturing. These are vessel, reaction vessel, reagent which are used, solvent which is used, intermediate formed, Then certain hazards. Hazard means what? Accidentally some contamination is there. That is particulate contamination, process error, packaging error, cross contamination, microbial contamination. So these are called manufacturing hazards. Okay. Improper storage due to the temperature or due to the stability reaction with the container. So this due to the improper storage, this stability issue may be there, and it can generate the impurity. Atmospheric contamination, then the deliberate adulteration. So these are the sources for the impurity. Okay. Raw material. If your raw material is having some impurity, then definitely this impurity will be transferred to the final product that you are making. So raw material will be including, if in case we are preparing any chemical in the lab, that will be used as a API, or your other raw material that is having impurity, that is transferred to the formulation dosage form that you are going to use. Say suppose we had the example of this copper sulfate. If you are using sulfate as your ingredient, and if the copper is prepared by the reaction of sulfuric acid on copper metal, and if this metal is containing some impurity of iron, arsenic and other, then along with the copper sulfate, that particular sulfate will be formed and it will be the part of your copper sulfate powder. So this is how the impurity can be generated from the raw material. Rock salt for the preparation of sodium chloride may be contaminated with small amount of calcium and magnesium chloride. So this is sodium chloride prepared from rock salt may contain traces of calcium and magnesium. Zinc sulfate, again similar process. If we are preparing from the zinc metal or zinc oxide, and if this is contaminated by the aluminum, copper, magnesium, manganese, nickel, etc., then this impurity will be there in your zinc sulfate powder. Fine. Method of manufacturing, reagent used. Say suppose we are again taking the manufacturing process of the calcium carbonate. So your sodium carbonate, which is taken in the manufacturing, and if your calcium carbonate contains soluble alkali as an impurity which is arising from the sodium carbonate. So what we are saying over here is, if you are using the sodium carbonate, it is having some impurity, alkaline impurity, and if we are preparing from this, chances are there that your impurity from sodium carbonate is coming into calcium carbonate. Similarly, we are having this example of ammoniated mercury, which is prepared by adding the solution of mercury chloride to the dilute ammonia solutions. Reagent used to eliminate other impurities. Say suppose one impurity is present and you are trying to remove chemically this impurity. So we are adding another reagent to remove impurity. So whatever the reagent we are adding will be now giving the another impurity. Solvent is important, and even many of the time major solvent we are using is water, and your water is having lot many trace elements like a calcium, magnesium, sodium chloride, etc. So if your water is contaminated, then definitely your product can be contaminated with this traces of the salts. Okay. Other solvents, if we are using, maybe it may be also containing some impurity like your alcohol or other solvents. And if it is containing impurity, we are using the impure solvent, this impurity can be transferred to the final product. So what we are doing, we are using sometime softening procedures, distillation will be doing removal of organic inorganic impurity, and many of the time it is considered, but it is quite time consuming and expensive also. Sometimes we are using demineralized water, where we are removing the sodium, calcium, magnesium, etc. from the water. Reaction vessels, many of the time your chemical reaction may be done in the vessels, metallic vessels like copper, iron. For heating purpose or any other purpose, you are using vessel which are made up of metal, and this metal may come up in your product even you are using it for processing purpose. Then also your reaction vessel may give you the impurity. Okay, intermediate which are formed. So you are using a manufacturing process, you are trying to manufacture something by using some ingredient, okay, but your final product uh, is forming in multiple stage reaction. Okay, these are the ingredient, some reaction number one, reaction number two. Now whatever formed over here are called intermediate, and if your intermediates are carried forward to your final product, then it will be having impurity. Similarly, here you can also have this example, like KiO3 is formed as an intermediate product, and if your Ki is containing this impurity of potassium iodate, then it is called impurity of intermediate. So in this case, what we can consider, multi-stage reaction is there, and your ingredients are getting reacted forming intermediate, and intermediate is carried forward to the final product. Then your intermediates can be there as an impurity in the final product. Manufacturing hazards. Okay, so these are the hazard which is coming from contamination majorly, or maybe some error particularly. So some of the particulate matter can arise by number of the way, such as accidental inclusion of dirt from the glass, porcelain, plastic, or other fragments. So whatever equipment apparatus you are using, that may be giving you that impurity. Errors in the manufacturing process. Sometime in a liquid preparation, there is incomplete solution of the solute, or similar error can be there. In short, we are using a manufacturing process, and due to some of the factor like incomplete reaction or any other uh, error in the following the procedure. So these are called error. These are maybe human error. We can say mixing, filling, tabulating, sterilization, and due to these errors, you are getting some impurity in your final product. Packaging error. Similar looking products are used instead of one another. So this can be due to the similar size, shape, color, similar pack. So even this can be leading to the impurity in your product. The handling of powders, granules, tablets in large bulk frequently creates considerable amount of this cross contamination. So we are using air filtration system. So this air filtration systems will be removing the particles which can be causing this airborne contamination or cross contamination due to air which is circulated in the manufacturing area. Microbial contamination. This microbial contamination can be due to the growth of microorganism in your solutions. Majorly solution preparations are having more tendency, wherever the water is involved, chances of microbial contamination increases. So we need to be careful about our preparation is especially. So microbial contamination, majorly antimicrobial and antifungal agents are added in some preparation wherever required. Storage condition. If your product is stored not as per the guideline which is provided, so maybe having stability issue, so temperature, humidity, sunlight, this can be the factor that can degrade your product. And after getting degraded, whatever degradation product form may be, uh, it is there as an impurity in your final product. So storage condition are also important where you are studying this source of impurities. So your filth, that is dirt, dust, some part of the insect are coming into the vegetable herbal drug majorly. So these are also impurity. Temperature effect decompositions. So these are also impurity. Storage containers, what you are using. Say suppose your chemicals or your ingredients which are reacting with your packaging material like plastic or glass, what you are using, then this may generate some another chemical, foreign chemical, whatever is there beside the formula, other ingredient generated by the reaction. These are called impurities. Chemical instability of the compound may also lead to the impurity formation. Atmospheric contamination may be due to the dust. Cross contamination can be there. Two products simultaneously prepared, and the particles of each other is available as an impurity in final product. Okay, so one of the example how the chemical is being affected by the atmosphere. Your calcium hydroxide and sodium hydroxide absorbs carbon dioxide when it is exposed to the open air. So this is how it is getting converted, sodium hydroxide getting converted to sodium carbonate, and it is having this impurity of sodium carbonate. Deliberate adulteration, this is done intentionally to make it cheap and to make it substandard, make it cheaper version to enhance the profit. These are the human tendencies, normal to make profit. So deliberate adulteration can also be there. Now, what can be the possible effect of impurity? If impurity is present in your preparation, if any impurity is present in your pharmaceutical dosage form preparation, then what can be the effect that impurity can have on your preparation? That first, it may be incompatible with other substance. It may lower the shelf life of the substance. So the expiry date, whatever is there in on the product, may get changed. Shelf life is indicating that. Impurity may cause difficulty during formulation and use of the substances. So if your ingredients become incompatible with each other, so problems may be there in case of the formulation where we are uh, creating formulation like suspension, emulsion. So technical incompatibility may be there. Impurity changes the physical and chemical property of the substance. It may prepare your compound appearing some smelly, filthier, looking ugly preparation that patient won't be accepting. So this is how it is changing the appearance of the product sometime. Therapeutic effect will be reduced. So the effect that is produced by a standard product, and we will say the effect produced by the product with the impurity will be obviously lesser. Toxic effect can be there over a certain time if your impurity is in higher amount, and if your impurity is like your arsenic salt or any other salt, it may be toxic, injurious when present about certain limits. So we are checking the impurity should be in the limit particularly. So lastly, it may change the odor, color, taste of the substance, so making it unacceptable for the patient. Some common procedure what we are using is washing. Uh, as we have taken this example of calcium carbonate, again we will be taking that sodium chloride is soluble in water, whereas your calcium carbonate is not soluble in water. So you are washing calcium carbonate powder with the water to remove sodium chloride from the calcium carbonate. So sodium chloride will be impurity over here that you are removing with the washing. So this can be one of the method. Drying some of the moisture content, and this moisture may further lead to the mold or fungus or any other microbial microbial growth. Okay, and this can be prevented by drying the powders properly. Okay, recrystallization, where your compound is only soluble in particular solvent and other part are not soluble, then getting your compound recrystallized will be the one of the method that you can use for the purification purpose. Sublimation, this method is applicable to very few substances, and this can be dependent on the nature of your substance, where like you are using camphor, benzoic acid, similar compound, then you can use this process for purification. Now, taste for purity. In the monograph, you will observe this title, taste for purity. So this will be including many of the tests that can either detect the impurity which is present, or it gives us a certain assurance on the purity of your compound. So both aspect will be fulfilled by this test for purity. Like it will be a statement in your monograph, it has to be tested for like this. For example, let us see, it has to be tested for iron, chloride, arsenic, heavy metals, depending on the type of compound, depending on the solubility, physicochemical property of the compound. Like, say, suppose we are knowing, again, I will take the example of calcium carbonate. Calcium carbonate is soluble in dilute mineral acid. It is not soluble in water. So, the taste here can be acid insoluble matter. So where we are checking that whatever matter other than the calcium carbonate won't be getting solubilized in the acid solution. So this test will be there as a test for purity in this case. So these are tests which are giving us the idea about purity of compound, or these are the tests which are giving us the idea about impurity which is likely to be present. So these are the tests for purities. Okay. So it may involve some basic data like color, order, taste, physicochemical property, where we are checking certain property of the compound. Okay, where you can check like acid value, saponification value, solubility. You can check acidity, alkalinity. Even for the bicarbonate, you will make a solution 1%, and you will check the pH of the solution. That is given as a test for purity. Moisture content can be tested by means of loss on drying. You can determine the radicals or the anion cations which are present in the compound. Like, say, suppose you can test for the presence of calcium, for the presence of carbonate, sodium, ammonium, whatever that is supposed to be present. Like in case of calcium carbonate, sodium chloride is impurity, so you will perform a test for sodium, you will perform a test for presence of chloride. So simply you will take the rinse washing what we have done, and you will add AgNO3 and you will check the presence of chloride. So this is how you can perform a test for purity. Ash value, where we are burning the compound and remaining residue will be estimated. This will give you some idea about inorganic substances which are present in some herbal crude drug or some organic compound. Loss on ignition, similarly, where we are igniting the compound, and loss on drying, where we are drying the compound at particular temperature and for particular time. Now comes your limit test. Okay, limit test is defined as a quantitative or semi-quantitative. Majority, what we are going to study and what we are going to perform in the lab will be normally semi-quantitative test, designed to identify and control small quantity of impurity which is likely to be present in the substance. So it will be for the identification of impurity which is present in small amount. Remember this, this is present in the small amount. So we will be able to identify the impurity and we will try to avoid the impurity in our preparation. So these are normally specific for the compound. Like for the chloride, we will use the same reaction which is there for the identification, like it is reacting with the silver. It need to be sensitive because the compound is present in small amount. Okay, so this is how we are testing impurity by limit test. This is the common apparatus that you can use. This is called Nessler's cylinder. So we are moving little quickly as this is the revision for some student who requested yesterday. Okay, so you are adding your reagents which are required for the chemical reaction. In the Nessler's cylinder, the reaction will be happening, and we will be normally having what? We will be having such chemical reaction that will be either producing the precipitate or color. This precipitate form will be dispersed in the throughout solution. This will be less in amount, this will be dispersed in the solution, so it will be reducing the transparency of the solution. It will be causing haziness, it will be causing turbidity, and this will be compared. Standard is prepared according to the pharmacopoeial requirement, pharmacopoeial standard. Pharmacopoeia will be suggesting this amount is standard, and what we are doing, we are checking either your taste is containing that impurity more than standard or less than standard. Okay, so based on that, the reaction is directly proportional to the concentration. So your turbidity is more, your impurity is more, your color intensity is more, your impurity is more. This is how we are performing limit test. Limit test for chloride simply it is based on the principle of reaction of halide with the silver nitrate. So chloride will be reacting with the silver nitrate, soluble chloride, okay, in the presence of dilute HNO3 and will form AgCl precipitate, and this will be appearing as an turbidity. So why we are using HNO3? HNO3, AgNO3 will be providing the common ion effect. It will be enhancing the reaction rate and the reaction will be feasible. That is why we are adding this HNO3 in the this limit test of chloride. Then we are not getting into the procedures. Sulfate. Soluble sulfate is having tendency to react with the barium. More with the barium, it is having affinity to get reaction. So sulfate is reacting with the barium chloride in the presence of dilute HCl. Again, this HCl will be giving us this common ion effect. It will be acting as a catalyst. It will be enhancing the reaction rate. And barium sulfate, what will be formed? Again, it is precipitate. It will be forming turbidity. Okay, it will be forming turbidity, and this turbidity will be evaluated. Iron. So iron will be reacting with the thioglycolic acid. Okay, so iron and thioglycolic acid will be making a complex called ferrous thioglycolate, which is a coordination compound, which will be a colored compound. A reddish purple color will be formed. Initially, you are using citric acid to make a solution, and then we will be making solution alkaline with ammonia. This will be required for the formation of this complex alkaline site. That is why ammonia is added, and after adding ammonia, you will get a colored complex. Then heavy metal. This is a common reaction, like your metals are having tendency to react with the sulfide and form a metal sulfide. Like either you can use H2S or you can use sodium sulfide. And this sulfide, metal sulfide will be little brownish color in the coloration. So this will be like color as well as the haziness in the solution like turbidity. So this is the common procedure what we can use for the metal. Lead, in case of lead sulfide will be formed. One more test is there, which is reaction of lead with the dithiazone. Okay, in the alkaline medium. This is dithiazone, and it is also called sometimes dithizone. Some people are calling as an dithizone. Okay, it is diphenyl thiocarbazone. Diphenyl thiocarbazone, but called this dithizone or dithiazone. In the alkaline medium, it will be making a complex, again a coordination kind of reaction with this lead, and this lead dithizone complex is a colored complex. Okay, so this is how you are using it for the comparison of the lead impurity. Arsenic. Arsenic, what we have learned, arsenic is requiring a special apparatus that is known as Gutzeit apparatus, and this apparatus is used for the limit test of arsenic. Arsenic is initially converted to arsenic acid, then arsenic acid is converted to arsenious acid, then this arsenious acid is reduced, then it will be converted to arsine gas. This gas will be forming a yellow color stain with the reaction when it comes in the contact with the mercurous chloride. Okay, so this mercurous chloride will be in the paper. The solution will be on the paper. This gas will be traveling through the tube in the apparatus. You can see the apparatus. Okay, in between the rubber bung you are having mercury chloride paper, and the gas from the arsenic will be formed arsine gas. So this will be traveling through this tube and forming a spot, yellow colored stain will be formed. This will be evaluated. This will be compared both in case of standard and taste. Then some cases that we have already discussed, that if your sample is little alkaline and it is forming effervescence, then we will dissolve first in acid, uh, let the effervescence to be settled down, and then we will use the solution for the limit test. Sometimes it is insoluble, or some portion of your compound is insoluble, then the reaction will be by the soluble ions only, then the insoluble part will be causing difficulty to see the turbidity. That is why the insoluble matter will be filtered out. Some organic acid salts may liberate free insoluble organic acid, again that can be filtered off. Colored substance can be decolorized by either by oxidation reduction reaction, like we are doing in the KMNO4, which is boiled, decolorized, and then limit tests are performed for the KMNO4. Okay, reducing substance will be reacted first with the oxidizing substance, and then we are conducting this limit test. These are the modification in the limit test based on your sample. So here we have concluded with the limit test, and we are done with the revision of our limit test. Okay, so now I guess those who were lately admitted now sorted with the chapter, I guess. Still, anybody, those who were lately admitted, and if you are still having query in this chapter, in this unit, then we can discuss. Okay.